Selangor. Kedah, Kelantan. Remember, your word is very important. Your word is very important. Don't think that only one word lah. Never mind. If everyone think like you, then you are the future. So you have the responsibility to vote for your state. So I no need to go back because I'm from Perak. So Perak we already voted for during the general election. So I'm not going to vote for this time. For those who involve members, you have to go back. Okay. So it's 12:15 lah. I think it's not yet. It's not. Let me count. 1, 2, 3. About 70-80%. So it's okay. So I think we should start our class. As usual. So a summary for the past few weeks, right? For the past few weeks. So this is a new topic. It's not relevant at all to the past search algorithms. No. It's a new topic. So before we start the new topic, let's summarize first. That what we have learned actually during chapter 2, 3, and 4. So chapter 2, chapter 3, and chapter 4. So these 2, 3, and 4 are basically for past search applications. So for example, Google Map, Waze. Okay, Google Map, Waze, Puzzle, the cannibal missionaries. And then in the chapter 2, we learn about the planning. Okay, so before we start the algorithms, so you probably have to formulate the problem. Okay, and also to formulate the goal. Okay, so you have 7 elements under the problem lah. So this one I'm not going to list out everything here. For example, successor functions, the state space, the stack cost, the path cost, right? So I think during the tutorial I already explained. Maybe not all of the group, some of the group already go through the tutorial questions. So I already explained to you how to define the problems and also as well as the goal. So you have a goal, optimal solutions, and also the abstractions. So this one you have 7 elements here. Okay, so once we have done the planning, then we move on to the algorithm. Okay, so we go on to the algorithm. So there are 2 types of algorithms here. So one is the blind search, or we call it as a uninformed search. So and then another one would be a heuristic search, or we call it as a informed search.
Heuristic.
Okay, so blind search is solely depends on the patterns. Okay, meanwhile the heuristic search, it depends on the informations given. Okay, for example, the time, the distance. So we're going to use this information to explore the path. Blind search here we have several quite famous algorithm. For example, depth first search, breadth first search. We have others more iterative deepening depth first search, so-called depth limit search, bidirectional search. But these 2 are the famous one. So depth first search is you go deeper and deeper vertically. Okay, vertically. Breadth first search, go horizontally. Okay, so depends on the patterns. So what is the limitation for blind search? You're going to waste a lot of time. Waste time and the memory, because even though you know that the solution is somewhere around here, you have to explore also, because it depends on the patterns. Okay, what is a heuristic search? Informed search, it depends on the time. So we have learned about the hill climb. The hill climb here is divided into 2 types of algorithms. A simple hill climb. So maybe it's discussion here. Okay, so we have a simple hill climb and steepest ascent hill climb. Like a superpower, you look back, then no sound. I can turn back, then it goes, yes?
You want to talk?
Okay, simple hill climb is like a depth search, right? So it explore. As long as the child node is better than the parent node, then we explore. We explore. So if the child node is worse than the parent's node, then we stop it here. Steepest ascent is we explore O, we choose which one is the best, okay, then we explore. Let's say this is the best, we explore. Okay, so this is the best, we explore. Okay, if the child's node is worse than the parent's one, we stop here. So the problem of the the hill climb here is local maxima. So this one you have seen, we have a foothill.
Plateau.
What else?
Plateau.
Plateau, yeah, very good. And ridge, right? And then we improve these hill climbs using best firsts. Right, best first is a combination of a breadth first and also depth first. And then after that we have a A star. Right, very good. So best first we use a heuristic cost. A star we use
Functional cost.
function cost, which is the path cost plus the heuristic cost. So the way they expand are the same. So last week I already showed you the path, right? How to use the open and close to expand the path. So this is a summary of the chapter 2, 3, and 4. It's about the path search. So now you learn about the path search, you can actually build your own applications. Let's say the Excel puzzle, you can play with your sibling. Okay, see who win the games, right? You know already which path is actually lead you to the least number of stations or least number of steps. Okay, morning, afternoon. Okay, so yeah. So let's move on to the new topic called knowledge representation. It's one of the very simple topic I would say is overall in the 13th chapter is considered a simple one. So forget about this. You can throw this chapter 2, 3, and 4 into dustbin before the midterm test. You have to revise. Now you can keep away. So we are going to move on to the new topic called knowledge representations. So in the upcoming chapter 5 and 6 here, okay, chapter 5 and 6 is about NLP. Okay, natural language processing. So I believe you have gone through the practical for NLP. So you know what is NLP, right? Natural language processing. Before we build any NLP, natural language processing, the first step we have to do is to represent the knowledge first. So what is knowledge representation? It's a very important process to organize, structure, and also store the information so that the machine and the human can understand easily. Okay? So what is the knowledge representation? It's a process that used to organize, structure, store the information so that it can be easily understood by human and also the machine. Okay? So why we need to structure the information or this? Because in our real life, there are too many words. There are too many words. For example, happy. Okay, for example, happy, we have excited, we have a sad, we have so many words in the life. So what is the relationship between this and this? So we have to declare first. We have to represent what is the relationship between happy and excited, what is the relationship between happy and sad. So we have to declare first. So why we need to declare? Because it is easy for the machine to understand. Machines doesn't understand the meaning, the actual meaning of what is happy, but they understand through what? Through the comparison. Okay? I repeat again, machine doesn't understand the actual meaning, just like human. We look at the dictionary, we look at the meanings, then we understand. But the machine no. Machine cannot understand the actual meaning, but they understand through what? Through this kind of mind map, a comparison between this and this, then they can understand. Okay? So look at this example here. Okay, so let's say now you go to the Google search, it's one of the NLP applications. You ask what is book. So you look at the result here, so you written your book proposal, what is ebook, then somehow you will see that why it show what is a novel. How come the machine knows that book has some relationship to novel? How this works? Okay, and also if you type half an hour, it will return you is half an hour 30 minutes. How does half an hour 30 minutes, right, equal to 30?
Who the hell asked this question? People also ask what people brain dead is it?
For example lah, so how does the machine knows that half an hour is equal to 30 minutes? What is the relationship between 30 minutes and half an hour? So it's actually done using techniques called WordNet. Okay, so what is WordNet here? It's actually a lexical database. Okay, that to store all the lexical means the meanings, the words lah, the words. Store all the lexicals in using so-called synonyms, antonyms, hyponyms. You do know what is synonyms? Synonym is like the words that having similar meanings. Okay, for example, happy, excited. So this is the synonyms. Happy and sad is the antonyms. Okay, so this is the synonyms. Okay, we have a hypernyms. Okay, we have a hyponyms. So what is hyponym? What is hypernym? Hyper is a kind of a concept, for example, flower. Okay. Hypo is a subclass to the flower, for example, rose. A rose is a hypernym to the flower. Flower is a hypernym to the rose. So the word that's built through this kind of concept, through the hyponyms, antonyms, this and so on and so forth. So look like this word net. It's a net that consists of all the lexicals, all the word nets. For example, if you search for the book, it will lead you to the novel. Why? Because in the word net here, there is some relationship between the book and the novel. Same goes to the half an hour. Okay, so there is a relationship between half an hour and 30 minutes. So that's why in the Google, if you type half an hour, it will return you some response related to 30 minutes. Okay, because there is some relationship. So who built this word net? It's actually built by one of the university called Princeton University. Some researchers, they find all the words, they understand the meaning, then they build the word nets and then they put it inside the Python library NLTK, then you can use it. For example, I'm going to show you one here. Okay, let's say word net is also one of the very powerful so-called lexical database in NLTK. So let's say now I'm trying to ask half an hour. Okay, so what is the synonyms of a half an hour? If I run this code, so it will return me 30 minutes. So there is a relationship between half an hour and 30 minutes. So no matter you ask 30 minutes, the machine will know that, oh, this is actually half an hour. Okay, there is some relationship between these two terms. Okay, so there's no antonyms for the half an hour. The synonyms in the word net is called syntax the syntax it's just a terms. Okay, so that's why knowledge representation is very important. It's very important that how do we actually represent the knowledge from the unstructured data to the structured data, so that the machine can understand the so-called meanings, but not through the actual meaning, but through maybe the relationship, through the comparison, through how you represent the knowledge. Okay, you will represent in the wrong way, then the machine will interpret wrongly. So one of the reasons why you need this one is for the machine to interpret, to analyze, and come up with the conclusions. Okay. All right. So there are several techniques to represent the knowledge. Okay. One of the famous one is called semantic networks. Okay. Semantic network is a network to show all the semantic. What is semantic? Semantic means the kind of words or the meanings. So you have a network to represent all the semantic, all the relationship. What is conceptual graph? So we have a semantic networks, conceptual graph. We have an or graph. Okay, and the last one is the frames. So each technique here has its own purpose So normally we use a semantic network and conceptual graph to show the relationship between the concept. For example, what is the relationship between happy and sad? What is the relationship between excited and happy? Besides, we also use the semantic network or the conceptual graph to show the sequence of events. Okay, for example, today you play games, so inside the game you fight with the boss. Okay, after the boss you win the reward. So it shows the sequence of events. Okay, so we use the AND or graph to represent the rule base. Okay, we have an example later. And last one, we have a frame. Normally, we use a frame to represent the properties of one object. Okay? So frame is not suitable to represent relationship or sequence of events, but it's more suitable to represent properties. Semantic net and conceptual graph is not suitable to represent properties because you're going to have a lot of branches here. So let's see the example of semantic networks. So this one is not important here. So what is semantic networks? Is to show the relationship to other concepts. So under the concept semantic networks, there are several terms that you have to take note. The first one is called node. I think it's shown here. Yeah. The first one, node. Node here is to show the concept. Okay, so this is the node to show the concept. This is a concept. This is a concept. And then the second one, we have this so-called edges of the label arch here. Okay, so we have a label arch here. Okay, normally it's a binary relationship. It's a binary relationship. So this arch here to join the concept, to show what is the relationship between the concept A and the concept B. Okay, and lastly, you need to provide the label for this label arch. What is the relationship between A and B? Maybe A is a subclass to B. That is show the relationship between the concepts. Okay, so look at these examples. We have a human, right? Human is a mammal, right? What is mammal? What is mammal? You know Chinese, right? What is mammal? What is the properties of mammal? Vertebrate. Then you have a backbone. What else? Don't know. Forgot already. Yeah, science. So human is a mammals. Other type of mammals like monkey, alligators. So human is a subclass. It's not an example, but it's a subclass to the mammal. Okay, mammal is maybe a superclass. Okay, then we show the relationship between human and the nose, right? Human, all the human we know that has a nose. Then we have a concept here, shown by nodes. Then we have a so-called the edge here to show the relationship. Human has nose. Then we have another so-called example or the instant. Okay, Simon is the instant to the human. So Simon tutorial group maybe in L1, and the fact Simon the favorite number is 888. Okay, so there's no such standard syntax for semantic networks. As long as the relationship here is logic, then it's considered correct. You can use your own so-called the terms here, right? Maybe Simon, a tutorial group, okay, can also. Simon, lucky number, can be 8. Okay, so it's up to the user how to define the terms, the relationship. But somehow, but for the is and instant, you have to take note lah. So it's quite different between is and a instant here. Is so a subclass. Human is a subclass to the mammal. Maybe you have a monkey is a subclass to the mammals. But Simon is just one of the examples. For example, you have Jason is instant to the humans. Me is instant to the humans. You have a vehicle. Vehicle is a class. Then maybe MPV car is a subclass. It's a subclass to the vehicle. Aeroplane is a subclass to the vehicle. Okay, and then you have a lorry, it's a subclass to the vehicle. So what is the instant? You have maybe a car plate ABC 1 2 3 4. That's car plate 1 2 3 4 is a instant. It's an instant to the subclass called car. Okay, so there's a difference between instant and is a. Okay, so Xinchang is 5 years old. Is Xinchang still 5 years old now? Anyone? Xinchang fans? Yeah, you. How old is Xinchang? 5. Forever 5.
Yeah.
Why?
Because of that.
Why forever 5 years old?
Don't know. American cartoon Simpson also
Oh,
forever.
Okay. but I'm not favorite of Xinjiang, so a bit rude, Xinjiang, a bit hams up. Yes, but I never watched, I know that it's very hams up. Okay, so it's 5 years old. So how to represent this in semantic networks? So we know that Xinjiang is one of the concept. 5 years old is one of the concept. So we want to join these two concepts together. So Xinjiang, 5. Okay, so age here. So and then you have to take note on this the error here lah. So we cannot put the 5 back to the Xinjiang. It doesn't make sense, right? So we know that Xinjiang age is 5 years old. If you put the errors in another way around, then something wrong. It's wrong. Okay, Tweety the bird can sing. So we know that Tweety is a concept, bird is a concept, sing is a concept. So we can put Tweety. Okay, Tweety is one of the example. It's instant to the bird. So this Tweety can sing, right? So if you don't want to put the can, also you can put ability. Ability sing. So it is very freestyle. Use the semantic networks. So why semantic network is very important? One of the reasons is it helps the machines to analyze or to interpret the concept between each other. For example, if you go to the Google search, you type what is ostrich, then based on this map, the Google will turn you ostrich is actually is a bird, okay, which can run and it is very tall. So it will show this relationship, then it will return you the proper message back to the user. Then you will type what is animals? Maybe it will say animals can breathe, has these properties, has skin, can move. And then it will provide you some other examples. What are example of animal? Then it will provide you a bird, fish, and so on and so forth. Okay, so this is one of the this is how the so-called the search engine works. We have this map, so the so-called engine will try to analyze. You're looking for animals. So what are the concepts that link to animals? That it will return you. It will return the result to you on the page, in the Google search page there. Okay, so this is one of the examples of maybe questions. Represent the terms below in one semantic network. Edward is a vampire. Edward's girlfriend. Bella is a human. Jacob is a werewolf, and Bella are childhood friends. So werewolf is the enemy of for vampires. Anyone? Huh? You've got the two thinkers here. Anyone? Nearby? Outside easy to walk here. Blender, okay. Blender. Draw some picture for this question one. Semantic networks. Okay, good. Brandon is a vampire. Brandon girlfriend, what is your girlfriend name?
Nicole.
Nicole is a human. Brandon is a hams up low.
Brandon has 10 years experience.
Of what?
Hams up. Sexual harassment. 小姨中文是骚扰圣洁，中文是骚扰圣洁。
做乜手？
大概那个。Brandon。所以你们吃了吗？所以你跟你吃了。那个09那边不是刚才都是吃。你啊？跳舞去。我没吃，干嘛？越南没吃，好吃吗？你要真的好。这 TVR 不是？ 还慢慢吃，环境问题会淡了吧？这样吧。
Thank you very much.
Brendan, in love. Edward's girlfriend.
Where girlfriend broke up. Okay. Okay, thank you. So let's see. Okay, Edward is an empire. So Edward is instant. Edward is a subclass or instant.
Instant.
Instant, no?
Vampire.
More appropriate to put instant, right? So this one should be an instant, Edward is one of the example because you have others vampires, right? So just one of the example to the vampires. Okay. So Edward girlfriend Bella. So what is the relationship between Edward and the girl Bella? Is a girlfriend of Edward. So Bella is a human. So Bella again is a instant. Okay. So is a human. So, Jacob. What is the relationship with Jacob? Is a werewolf. Again, this is an instant. Okay. So Jacob is a werewolf and he's a Bella childhood friend. Okay, and the last one is the enemy. Okay. Okay, for vampire. All right. So it's very simple. If you have these kind of questions, you don't make any mistake lah. Okay, so we kind of bonus mark. So you have a concept, you have a relationship, you just join the concept using the ages together with the label, a proper label. Okay. So this is one of the past year questions. Yeah, I give you about 5 minutes. 5 minutes to try these questions. Represent the terms below in one semantic network. So in one, so it means that in a whole, you cannot separate into different or partitions semantic networks. When traveling to a new place, there are 3 options of staying in: hotel, farm, homestay. 3 lodgings offer a variety of facilities. There are animals in farm, rabbits and sheep are both common. Homestay, on the other hand, have a shared lounge and free Wi-Fi. What you play aeroplane? You doing recording Recording
甚至这样做，他只用3个 facility，
2个
不是只有2个吗？他在骗我。我都睡这里家。
学霸给他多少？赚，我很见到。那个对。
Brandon, you point one of your friends. Which one that you liked the most? What's the name?
Brian.
Oh, Brian. Okay. Brian?
ใช่จู
Brian? The answer is here.
Hả?
This is the answer.
我的被剪掉了，我的被剪掉了。
意思我们可以看到。
哦，真的有。
像
You
我
can
吗
zoom in. You
Why
can.
so
You can.
this one mine is small as shit.
真的吗
1, 2, 3, 4, 5, 6, 7. 别拉着点，能剪吗？
我的懵掉了
Yeah. Compare your answer with this answer.
哇塞
So
โอเค
we have a 3 launch, right? So have hotel, farm, homestay. So there has a facility, and then water heater and sauna is they are subclass. So homestay has a launch and has a free Wi-Fi. Farm has animals. Sheep is the animal. Yeah. Okay. Very simple, right? Okay.
Don't.
When
do we use this and then or instance?
Instant we use when is so called what like
properties
is we use is when it is a subclass. Okay, for example, you have a vehicle. So car, airplane, trains, they are all a subclass to vehicle. Okay, so maybe under the car you have one instance of car with the car plate number ABC1234, and this car here is actually one of the example to the car. So you have so many cars, right? So then this is just one of the example. This is instant. Okay.
Can we say like the sauna and the water heater is an instance of?
They are actually one concept. They are actually one a class. They are actually one. They are considered because under the facility there are so many classes. You have a sauna. You have a water heater. Maybe you have so-called the washing machines. But then under the washing machine you have maybe washing machine, the brains, kins, and then model ones. Yeah, so that will be the example. Okay. All right. So it's not difficult, right, for semantic networks. So it's quite simple. As long as you identify the concept, the ideas, then you can actually join the concept together. Okay, so we have more questions here lah. So again, like university is one of the top 20 university, established is 1950. So blah blah blah. So this one I let you try it at home lah. You try to identify the concept as well as the relationship. So you do yourself lah. Okay, so I just want to show you how do we build this semantic network using the Python. Maybe you got okay, we learned this theory, then how? So how to put it inside the Python, or how to build this semantic networks. So one of the example is the WordNet that already built by someone by this Princeton universities. So how about, let's say now we would like to build our own semantic networks. So there's quite many library variables in the Python here. One of the famous one is called network X. So one of the library that you can use to build the relationship. Okay, let's say now we like to have a relationship dot animals. So that is animals. Cat is animals. So animal is a mammal, right? So just now we learn about the animal is a mammal. So this is where we add the relationship. So this is just a graph right? How do you want to draw the graph using a thick, how thick of the edges, okay, and so on and so forth. So if I run this code, then you will see, okay, so you will see this semantic network. Animal is a mammal, okay, dog is an animals, cat is an animals, okay. All right. So is there any questions so far for semantic networks? No. Okay. Good. Then I will proceed. So this one we have learned just some examples of semantic network. Let's say you have a rover, the dog bite the Peter, the postman. Then you can say, okay, rover is just one of the examples. So instant to dog. So rover bite the Peter, Peter is just one of the example to the postman. Okay. So you can actually extend or modify this simple semantic network to a more complicated one. You treat this byte here as one of the event. Instead of just one of the relationship, you treat the byte as one of the event into this. Okay, you treat the byte as one of the event, and then you have you can create one subclass or one example. It shows that this big B here is one of the example. So in this event here, who is the agent? Lower. What is lower? Lower is the example. So inside this event here, who is the victim? Peter. Who is victim? Peter. Peter is one of the example to the postman. So there's no wrong or right. You can use this way or you can use this way. Okay, it's up to you. Okay, so this is non-quantified semantic networks. Non-quantified means that the event is specific. You know that rover will bite the Peter. But sometimes you may have some statement, a general statement that shows that it's a quantified statement. For example, every dog bite postman. Okay, it is a general statement. So if you have a quantified so-called quantified terms in your statement, for example, every dog, some dog, then you cannot use a simple semantic network to represent the knowledge. Instead, you have to use a partition semantic networks. You have to use two different semantic networks to join them together. Okay, so we can actually draw the semantic network for dog has bitten the postman first. Okay, so this every here is actually a quantifier. So we leave it, we leave it first. Okay, we draw the semantic network for this part. So we know that this is a byte event. So B is the instant of the byte, and then inside this event, who is the agent? Okay, we have a D here. So what is D? Is an example of dog. Okay, what is P here? Is just an example of postman. So this is one of the semantic network. Then we create another semantic network here. We know that this is a general statement because it's not specified like the previous case. So we know that every dog. Then we create a general statement. And then G here is just one of the example. G is an example to the general statement. And we point this general statement here to this semantic network to join these two together to show that, okay, this general statement form this event. At the same time, you have to find which so-called concept is having the quantifier. Let's say this is dog, every dog here. Okay, every dog. Then we join this every here into the example. And this D here, it shows that every dog. So this symbol is referred to every. So it means that every dog bite the postman. Okay. But this is not very important lah. Just additional information to you. If let's say we have a so-called the quantifier every. If you have a some dog here, okay, some, then you have to use this symbol lah. So this is all. Okay. So let's say now you have every dog has bitten every postman. Okay, if you have every dog has bitten every postman in this case, then you have to join this statement here. Okay, create one line to show, okay, all postman, all dog here, and then at the same time you create another line to link to this postman and put this symbol. Then from this diagram we know that every dog has bitten every postman. Okay, is that clear? Okay, so okay, just now we learned about binary predicate, which is the direct relationship. For example, the first one, Ronaldo Real Madrid. Okay, so we have a Ronaldo Real Madrid. It's very simple. Then you have a two concept here. Okay, Ronaldo maybe team is Real Madrid. Okay, this is binary. But let's say now we have a non-binary predicate. What happened? So this second example here shows non-binary predicate. You have a three concept here: Real Madrid, MU, and 1-3. Okay, it means that in one event you have a three predicate here, three object here. So how to generate the semantic network for this case? Then you have to think a keywords that how to join the concept together. In this case, I'm going to use a keyword called features. Okay, features is one of the subclass to the football game, and then you join the three predicate here. You have a Real Madrid, MU, and 1-3 here. So we know that away team is Real Madrid, a home team is MU, and score is 1-3. If you cannot think the keywords that how to join this predicate, then you can just use the terms called event. Okay, so event is just one of the example. For example, in this case, John gave the book to Mary. So we have a John, a book, and Mary, right? Three predicates. So this event is about give here. So we can just click a one keyword called event. So what is this event? This event is actually one of the example to give. Okay, so in this event, who is the agent? John. Okay, so who is the receiver? Mary, right? Mary is the receiver. And what is the object here? Book. Okay, book here. So you can just write the name of the book lah, and then book 69 is one of the example to the book. Okay. Yeah. So let's say now you have a question here. Simon has what? Okay. So based on this semantic network, then you can tell, oh, Simon is actually a human. Simon has nose. At the same time, Simon is a mammal and has skin. Then based on the third question, then you can say, oh, Simon has nose and has a skin. And this is how a machine interprets also based on the semantic networks and return the appropriate response back to the user. Okay. So sometimes we use the semantic network to compare the two objects. For example, in this case, okay, so we want to compare the height of Dave and also the Steve. So Dave, okay, so you can point to the H1. You just click one variable here. Okay, it shows that this is just one of the so-called variables. Then this variable is greater than this variable. Then you can put a value here. What is the relationship between these variables and this value? Okay, 160. Okay, it's greater than. Okay, so there are many ways to represent the semantic network. If you don't want to treat the two variables here, then you can also put maybe we don't want to click this variable, maybe you can write in such a way. And Dave, okay, the relationship between that and so this is the value, maybe 160, right? Okay, and then you have another concept called Steve. Okay, also you have a height 158. So this is greater than, not greater than, also can. It depends. It's a very flexible to use semantic networks. Okay. Okay, so this is just a prologue. Forget about this. It's just one of the techniques. How do you code your knowledge? After you prepare the knowledge, right? After you prepare this, you have to put this into the coding. Just like how I put the code inside the network X just now. So what is the advantage of and also the disadvantages of the semantic networks? Easy to visualize, right? By looking at the semantic net, then you know what is the relationship between one and another. So related knowledge is easily categorized. The knowledge engineer can arbitrarily define the relationship. Limitations is no standard. As I mentioned, it depends. Every user may have a different interpretations, use different keywords to represent the concept, and it is not suitable to describe the attributes. Remember, it is not suitable to describe the properties or the attribute. Okay, it is not suitable. Okay, so next one we have a conceptual graph. So I'm not going to. So details about talk about the conceptual graph. The ideas of the conceptual graph is about the same like the semantic networks. Conceptual graph used to represent the relationship, but the difference here is semantic network is more towards a binary relationship. Okay, binary graph is to show the simple relationship. But the conceptual graph here is mainly used to solve a more complicated, complex relationship using a bipartite graph. Okay. Okay, if you know the semantic network is good enough already. For this conceptual graph is just additional information to you, how to represent the knowledge in a more complicated way. One of the main difference between the conceptual graph and also the semantic network is the node, right? Just now we have a node to represent the so-called concept, and then we have an edge here to show the relationship. By using the conceptual graph, we want to transform this into this. Okay, Ronaldo. Okay, so team, the Real Madrid. So this is by using a conceptual graph. This is using semantic networks. So we have to use a node to represent the relationship instead of just hang upon these edges. This is the only difference. Okay. So something like this lah. So just now we just put the arrows and then put the relationship. But in the conceptual graph, we have to represent the relationship using the what? Using the nodes. This is the only difference. If you would like to know more about the conceptual graph, then you can explore lah by yourself. Okay, I'm going to go to the third one. It's called AND/OR graph. So AND/OR graph also known as the hypergraph. Sometimes it's called as the inference networks. Infer means that to interpret. Okay, so mainly AND/OR graph used to represent the rules. To represent the rules. It's not the relationship, but more toward the rules. Okay, let's say now you have this example. Okay, so this is actually a rule base. You have 3 different rules here. If John smiles, then he looks handsome. If John is tall and strong, then he looks handsome. If John does exercise, then he is strong. Who is John? Anyone named John? No. Okay, so let's see how to build the AND/OR graph using these 3 rules. If John is smile, so this is the first condition. Smile. Then he look handsome. Then we put an arrow here. So handsome. Okay. So look at the second one. If John is tall and strong. If John is tall and strong. Okay. John is tall and strong. So if we have a keyword called AND, if we have an AND, then we put a join here. Okay, to show that you have to fulfill these 2 conditions in order to give you this conclusion. So we don't have a join here because rule 1 and rule 2 are separated. Separated. Then the third one, if John does exercise, then he is strong. So you does exercise, then you are strong. So this is the AND/OR graph to show the condition, which condition that can lead you to the conclusions. Okay. Okay, so you have this exercise or not exercise question here. Can you try these questions? It's one of the passive questions. Before you zoom in the answer you try yourself first, then and you compare. Okay, so forget about the CF value here. So this is so-called uncertainty factors that you're going to learn in the chapter 12. Forget about this. You just based on these 3 rules, build the AND/OR graph or the hypergraph. Okay, to test your understanding. So I'll give you about 5 minutes now. 5 minutes.
速度很快哦。可以耶。我教你screenshot 再看看。我试过。可以。对了，我没有打量。
送我一下。应该回家了。回家。不舒服。我操。我这。嗯。
Thinking. After you finish, you come outdoor lah. See you lah, handsome boy.
The guy with beer more handsome. 遇过大部分英语
啊，大部分
英语他们读的不因为都会改他们你对他们好一点，反正他们会得寸进尺，所以在用这种人的时候要很小心。他们会讲到慢，我相信你。
对，他们能力。就是你
是这样的，每一种工作不一样。像伪装这种工作，你就给他够的钱，他就帮你做完所有事情。
哦，这样好，就是
一年仔，
你给我钱，我谈的那边。
一年仔你给他多钱，他会跑路的。没有，他跑之前还会听你讲。
是会有，
是啊，大部分啊，大部分
是这一套，
不是讲
还是跟 online
是大部分遇到的。
我们是 work smart，是 work hard。
所以这种要给多够钱。
给我多钱，因为他们会睡觉。
我要有问题，你在解决，你就怎么事情。
然后班的话，1、2、3、4、5、6、7、8、9、10。没有来得及拍出来。那个人进来，这个人很适合做表情。你拍的。我周末是去见。上。我发大的。我去919了，偏偏一下身体。电话去就可以了。我是不是很聪明？可能下礼拜去找他。拜六节日晚上。这个拜六。这样早。这个一个考试。考梦。梦。我会6哦。吓死了！我会6考不到。V7考。对，4是别人的。
你吃不去。
这个礼拜，这个礼拜去3个礼拜。哦。等等。可以呀。下个拜五。下个拜五。哦，没问题。这礼拜。
Okay, thank you. So let's see. Rule by rules, we check the first one. The car exterior conditions are poor, or the car interior, okay. Exterior, interior, okay, good. So you don't have a joint here because using or. Rules number 2. The car mileage exceeds 150. Okay. The car engine is noisy. Okay, so join together. Okay, then you give overall is poor. Okay, and the last one. Rule number 3. The car service doesn't follow the maintenance and the overall condition. Okay, very good. Simple. Okay. So if you have this kind of question, make sure that you score also lah. You just need to identify the conditions and also the conclusions. Okay, very good. So last one will be the frames. Frame is about the same like you build the class, the class diagram using the word Java. Have you learned about Java, the class? What?
Object oriented.
Object oriented. Then you build the class object. Yeah, it's about the same like that one. I didn't learn, so I don't know how it's like, but I know that it's about the same. You have a class of class here. So the purpose of the frames is mainly used to represent the properties or attributes. Okay, properties or the attributes of one concept of one object. Okay, so this is the example of how the frame works. So remember, to build the frames, there are three important elements you have to include. The first one is the class name here. It's a computer. So this is the name of this class. So you have to indicate here. The second element is the attribute, the properties. Okay, the third element here is the value here. Is the value. If you don't have the value, you can just actually leave it blank. Okay, you don't have a value, you can just leave it blank. And in this case here, we know that you have a class or superclass called computer. And we know that computer, you have a stereotype of attributes called models, processor, memory, price, and we have an arrow to show a relationship. Okay, Asus is just one of the so-called examples of the computer. Okay, so Asus, the superclass of Asus is computer, and then you have you can actually put the so-called value. Okay, what are the properties for the Asus? So what is the advantages for the frames here? It's more structures and organized, and you can't actually use the semantic network to represent this. Can, but it will be very messy. Try to imagine that how are we going to convert this computer to the Asus. Then you will have a lot of nodes here. You have a computer. Okay, then you join to the Asus. Okay, then you have a lot of properties. Okay, and then computer you have also the own properties, the default properties. What if let's say computer you have an event? Okay, this is just one of the examples. You have other brands, right? Then your map will be very big, and it is not suitable to use frame to represent the to use a semantic network to represent the attributes or the characteristic. Okay, so what is the advantage here? Is more structured, organized. To represent a stereotype object. What is stereotypes? Do you know what's the meaning of stereotypes? Stereotype means what? Means it's a the typical properties. Like when I say a female, so what is the properties that first come in your mind? Female, long hair, huh? Stereotype. I don't mean that short hair is not like female, but I mean the stereotype, the first the ideas that come into your mind when I say what is the properties of female. Then you say okay, long hair, wear skirt, okay, a sweet smile. This is the stereotype properties. Okay, typical one, typical ones. Okay, describe various attributes and characteristics of object and real-world entity. So implicit connections of information in the problem domains. Okay, it's not only to show the properties, but it's also show the inheritance, right? This Asus is actually inherit from the property from the computer. Okay, so remember you have three elements: the name of class, the attributes, and also the values. Okay, so let's say this case, another example. You have a birds, right? So birds is actually what is the properties? Have a feathers, locomotions, can fly. Okay, and then you have an ostrich. So you can put is a means that we know that this frame, this is actually one frame. Ostrich is actually a subclass to a bird. So bird is a superclass. Ostrich is a subclass, and the locomotion is walks. Okay, mammals, walk, hair, locomotion, walk. So this is another so-called class here. So if you compare to the Java, you want to create a so-called subclass, then you use extend, right? You use extend here. So if you want to create an instance or examples in the Java, you use a keyword called new. Right? You still remember lah. Okay, so it's about the same. It's about the same. It's mainly used to represent the properties. If you are very good or if you learn about the Java, then so that be a problem for you to build the frames. Okay, so this is another example. Yeah, computers. This is not an example. Same like previous one. So you can actually further extend the class, the frames previously into this format where you add two more informations. The first one is called data types, right? So you want to show what is the data type for this value, then you can include. Okay, so this is actually a string. 2 is actually a number, numeric, then you can put an n here. So 1 billion is actually a numeric, then you can put an n here. So this is just an additional information. It's optional. You don't put also never mind actually. Okay, the second information that you can put inside a frame is called a facet. Okay, so facet here is to add the information. So what is the meaning of these two? What is the meaning for this 1 billion here? So default here, it means that when this bird borns, right? So we know that by default it has a 2 wings. So what is initial means that this initial means that at this moment you have 1 billion populations of the so-called the bird. Maybe after 10 years, it reduced to maybe 1 million. So the value can be changed. Okay, but the default cannot be changed. We know that by default human we have a 2 legs, 2 hands. But initial means that the population maybe after 5 years the population of human in Malaysia maybe reduced from 1 million to maybe 5 million. Initial is a value that can change. Okay, but again it's optional that you want to put the data types or you want to put the facet. Okay, it's up to you, but the 3 elements that you must include will be the class name, the attributes, and also the value. Okay, so what is the disadvantages of frames? It is very difficult to program, especially making inference. Unlike the so-called the semantic network, is easy to make inference. Right? What is the Simon just now? Simon has no. So look at the map, then you'll know that what are the properties that Simon has. But by having this frame, is very difficult to make inference. So this is one of the examples that I can create the frames in the Python. Okay, I'm going to show you one example here. So not this one. Okay, this one. Okay, so I create a class called car frames. Okay, so this is the name of a class, and then I have a so-called the attributes, right? Manufacturers, models, year, colors, engine size, and then none here is means I don't have any value at this moment. So I just put a none. So this none here is referred to the value lah. Okay, so you have a class name, attributes, and also the so-called values. And then I create the instance, a car instance. So this is just one of the examples. So this car instance is inherit from the superclass called car frames. And then under the car instance, I have this so-called attributes. Then I can insert the value. So this example of this car is actually a Toyota Camry from 2022. The color is blue and so forth. Okay. So compared to the semantic network, it's more organized, it's structured, but it is very difficult to make the inference compared to the semantics. Okay, and also the limited not suitable to describe the sequence of event. Okay, so unlike the semantic network, just now what I say is like you have some battles, right? Battle in the game. So you have a game here. Then it can show you have a battles. You want to fight with the boss. Okay, after you fight with the boss, then you have a reward here. Okay, so what is the reward? Maybe some coins, 1 million coins here. So you can show the sequence of the event in semantic networks, but it's impossible that you represent this knowledge using frames. So how can you represent the sequence of event using frames? It's impossible. Okay, and also non-description on syntax semantic of a sentence. Okay, so this is one of the main problems for the frames here. So what is the syntax or semantics ambiguities in sentence? Okay, for example, in this case, I use a semantic networks here. If I have a bank here, I have a keywords called bank. So I know that the bank can have multiple meanings. So this is maybe finance. So maybe this is called a river bank. Okay, then I can further expand. Okay, what is the meaning of finance bank? You have a Maybank here and here. Where's the river banks? But using a frames is impossible. You can't represent this semantic so-called ambiguity using a frames. It is possible. Okay, incomplete informations. So just now we have learned about a semantic network. We can use a partial semantic network to show the or some or dot but or postmate, right? You can draw a semantic networks here. Okay, then you can put this or. But using frames again, you can't represent this information. You cannot. Okay, so it depends on your questions. Then you decide which technique to use. Not all the information can be represented by the semantic networks, as same goes to the frames. So it had to depends on the information. So what is the advantages of frames? Easy to understand, right? You have a frame, very organized. You have the details, the properties of each of the objects, and it's very flexible. You can easily add the class, you can easily add the properties, or easily detect the missing values. Unlike the frames, unlike the semantic networks, if you have a very big semantic network here, you may miss out one of the important maybe elements or the properties. But through the frames, you can easily spot the missing value or the missing properties. Okay, so yeah, I think this one you're better than me lah. Okay, so what is the facet? As I mentioned, facet is to add more information. So what is the value? It can be default or it can be the initial. Okay, like the case just now. Okay, so slot. What is the slot here? Slot is equal to this. Okay, so in slot you can do many things. You can put the value. Okay, if you don't have the value here, for example 1 billion 2, you can leave it blank. Okay, otherwise you can also add description. For example, in this case, if you don't have a value, you can also add a description for the particular attribute. For example, team. Team is a class, the cardinality. Okay, so you can also add the description here if you don't have any value. Okay, another one here is you can use the slot as one of the class. Okay, you can treat the attributes of one subclass as another class. For example, in this case, let's say you have a baseball team. So inside the baseball team, you have several properties like cardinality, team size, and managers. So this manager here, the property itself can be another subclass. Okay, then you can further analyze, further so-called describe what is manager. So manager is what, so you can put the names, okay, you can put the numbers, you can put the location, and so on and so forth. Okay, and then lastly is the daemons. So daemons is in the Java is called methods, right? Methods. So what is the purpose of these daemons here? So if you refer to the previous case, the value that we put here is so-called static. We cannot change the value, right? Once we define, then that is the value. So daemons here is used to dynamically modify the value if you have something happens. Okay, let's say now you have a new value that put inside the slot, then something will be triggered. So it seems like the methods. But for your information, you don't need to memorize the methods inside the frames here. It just show you some of the example. If added, if removed, if needed. Okay, so I'm going to show you the code, then how we can actually create the daemons inside the frames. Okay, in this case, let's say now we have a temperature. So this is actually a static value, here. Then we can create the so-called the methods, okay, or called as a daemons lah, okay, to modify the temperature, So this is the functions, a kind of functions where you can modify the current value to the latest value, or it's called daemon. It's a method. Okay, so if I run this code, so what will happen? So you can actually initially from 0. So now I have something happen. So I can actually modify the value from 0 to 25 degrees Celsius. Okay. So these are some of the examples what you can do on the slot. You can actually put the value. You can also put descriptions. You can also treat the properties as one of the subclass, or you can treat the attributes as a daemons, as a method. Also can. Okay. So let's continue. So sometimes you may need to convert or transform the semantic networks to the frame. For example, in this case, you have a semantic network. Player is a team. Another is the example of players. Players play football. Okay, so you have to convert this semantic network into the frames. So how to convert? It's very simple. You have to identify how many concepts they are actually joined with this keyword called is or instant. Okay, in this case, in this map here, you have a 3 concept. Team, player, and Ronaldo, they are actually joined with this keyword instant and instant is then we can actually create 3 frames. Okay, team, player, and Ronaldo. Okay, so like this, team, player, and Ronaldo, they are actually connected with is and instant. Then we know that they are actually 3 frames. So after you click the 3 frames here, then you can put what is team? Team is actually a superclass. Okay, so what is player? Player is actually a subclass to a team. So what is the properties under the player? What is the properties of a player? Football. Huh? And then what is the properties of a Ronaldo? So it's a team Real Madrid, but I think this is an old slide. Ronaldo is no longer in Real Madrid. Huh? Where is it now? Do you know where is Ronaldo? Where is Ronaldo? Where is Ronaldo now? Saudi. Saudi, I think it's not in the Europe country. It's go to Saudi, one of the football club. Okay? So how about this? So let's say now you have these semantic networks. So how to transform this semantic network to a frames? So as I mentioned, you have to identify there are how many concepts joined with is or instant. So from here we have bird, kernely, and treaty. Right, these three are actually a concept joined with the keyword is or instant. Then we can create 3 frames: bird, kernely, and treaty. Okay, so you can create bird, kernely, and treaty. So because we have a 3 concept here, you can create 3 frames. So bird, what? Bird is animals, right? So it's actually a superclass. You can actually, if you don't have the animal here, by right, this animal you can actually remove it. You can change to class. It's a superclass based on this semantic networks. Okay, and then the bird can fly and cover the feathers. Okay, so good. Right, you have a kernely. So you point here to show that there is a relationship between the bird and kernely. What is kernely? It's a subclass to a bird. It's a subclass to the bird. So what are the properties of kernely? Yellow and sound. Okay, then the last one, you have a treaty. Treaty, what is the? Treaty is an example. Example to the kernely. So what is the properties? Can talk. Okay, so this is how we transform the semantic network to the frame, but not often. Not often. Normally, we will represent the sequence of the events or the properties. Okay, using the frames or sequence of event using the semantic networks. Okay, so now let's look at this question back here. Can you try how to put this information or this knowledge using the frames?
是吗？你这样觉得？
We have a university is one of the top 20 universities, so it was established in the 1950. Okay, so it offers 6 programs as degree levels. Okay, as more than 45,000 of students, more than 10 countries, include international students, more than 10. Okay, can you find this using the frames to represent this whole paragraph? But in fact, this information is more suitable to be represented using semantic network. But somehow we still can represent this using a frame, so let's try. Okay, so what's your name, Wendy?
Me. Why?
You lost your name.
This is from Darren.
Talent. Point 1 student. Point 1 your best friends or
I don't have friend.
you don't have friends. Point 1 of your enemy.
That's why she chose her.
Huh?
She chose her.
Okay. Yeah. Jia Yi. She pointed you.
No, she chose anyone. I let her choose.
Oh, you let her choose. What is the relation between you and Jia Yi?
Class rep lah.
Oh, class rep. Okay.
No, don't. I'm in a relationship already.
Oh, okay. You're so nervous, really.
Very long.
Yes. 了，这我答案，是没有答案，有答案吗？
也是啊，真的答了。这把怎么是我们这把呢？是把呢？
这样子。
我们是把那个哦，又是哦。那你们呢？请喝椰子水吗？
有东西哦。
给太多了，人家头发啊，对。 天，你不要给我转去厕所。我也跟你做，我也这么有名帮你打这，那你选谁？真
摆在我那是一个
摔
回忆的。
了这么大，这是我哥做坏的。
哦，你去美东
我做坏的。
MCMD。是牛就去吃哦，是牛就吃哦。
怎么呢？
这个应该做对。
对，没有。
应该要拜五才可以有空。这个礼拜要内疚，使命酒，疯狂内疚。躺在床上睡觉。
什么鬼啊？
写上小给学妹看。
嗯？
来写上写给学妹看。
我也不懂，这样是不用写了吗？还要写啊？
现在不写，你跟他讲，我是星期要写，
哎呀，
星期半读不到嘞。
这还有别的东西？
我可是留不起。
大概
一直给了一个康，就是考，
所以我又跟你讲了，我是梦之舟的。你看你多少钱？
我大概全吧，错就错。
不要写那个，还是写，
我先说这个，你们
不要写
老师来。
反正
那
就这就好了。不要不要少了。不是快，sorry。
Okay, I'm not going to provide the oral pictures. As I mentioned, this is not a good example to use frame actually. But we can actually still represent this paragraph using a frames. So we know that we have a top 20 university, so it's actually a class. So you can actually put the default lah. So as I mentioned, slot here. If you don't have any value, you can just leave it blank. Okay. Then we show that it's a relationship. It's called college university. So this university is one of the examples from this frame. Inherit the properties from this top 20 university from here. So we know that establishment is about 1950, and then we can put all the descriptions and also the attributes. So you still have a number of student countries here. Then we can actually click another frames. Yeah? As I mentioned, the one of the properties, for example, the program. This program, you have a 6 different type of program, right? So for example, engineering, ICT, accountants, business. So you can create another frame to represent each of these programs, right? You have 6 program here. So if you have a value here, then you can actually put. But we don't have a value, so we just put it here. So this 6 program to show that there are actually subclass under this programs. Okay. Right, is that clear? Okay, yeah. So, if not mistaken, there'll be one question definitely coming up from here. let me find whether I do keep the past year questions. It's one the past year, huh? So
你们是做 OAD 的？你们做 OAD 做 report？对，选其中一个。report either OA。
this one simple. It just asks, okay, semantic and frames are commonly used. So explain the differences between the semantic network and the frames lah. Also provide one example to illustrate the semantic network and the frames. So in this case, you can just tell semantic network is more appropriate to represent the relationship or sequence of events. Meanwhile, frames is more towards like to show the properties, right? To show the properties and also the attributes. To provide an example, you can give a very simple example. For example, the Tweety is the bird, right? Tweety is the bird. So you just draw the concept as well as to join the concept and provide the relationship. So I want to give you some this one, yeah. Okay, so this is another good example. The information below describe the differences between the desktop and laptop. So you have a knowledge, okay, for example, blah blah blah. So frame in semantic network are common representations. So identify which technique is more appropriate to represent this information. Explain why. After you explain why, then you have to illustrate. Okay, so we know that from here you will have a lot of properties actually, like battery, power supply, large, not portables, okay, more powerful processors. So all these are actually properties. Then you can explain why frame is more appropriate because you have so-called the class, superclass, and as well as the properties to represent, right? There's no event at all. There's no event. There's no so-called the relationship. So it's mainly properties, right? Then you can use frame here. Then after that, you have to illustrate. You have to show how to draw the frames and store the informations inside. So since we have a time here, so can you try these questions? Okay. Jackson.
I'm Michael.
你是 Ken 不是吗？
I'm Ken.
You are?
Ken.
Ken.
那 Charlie 是 Bobby。Malaysia 的 Bobby。
Okay, can give me one name?
Yeah.
Your friends. Your
Alan.
friends. Brian.
Brian.
Okay, Brian. Yeah, Brian.
Brian.
还是送。
Brian Gunn。
来假了。
这是中文。
对啊。他是在我们做2还是1？还是在我们画吧？
他是没 spam 吗？
还是我们画？但恐怖都是 super car。然后is a super car。
那写呢？
是这个吗？
来写，看continue。
它 property 什么？不是，但是放进去。
Small easy portable.
好几盘这种。
Small easy portable.
还能考虑用摩擦的，就这几个。
Computing my laptop, desktop.
三个橙色的，还有尾巴。
Computer.
做这样，
这样行。
你觉得
laptop 是什么
size small
？small portable. desktop 吗？
Rest large, no portable.
还有什么？
laptop 是battery。
对，所以我才问清楚，可以说
battery 也没跑。
on battery。
多出一杯就是给他2杯啊。
然后另外一个是
一杯
only run manpower。
一定时高也是2杯。
laptop 是 battery or manpower。一个是 run manpower。
那是什么 power processor？
所以 desktop has more powerful processor。一个是 more powerful， 一个是 less powerful。
那还有什么？
那个也是那个写，好像写这边，还是在画多一个卡上去。要实一去。你要不要？
这应该是画下来的，然后就是这个跟这个，然后还有一个叫什么鬼来到 S Predator Harris
1日500。12个名来到。然后 powerful Intel 5 processor。
我去写。OK， 谢谢。要写。
Go go go！
哦，要写，要写。
早上开心，下去。
没问题。第二了。
9 marks, it's quite a big portion. 9 plus 2, 11. So if you can score these questions, that means that half. So this one is chapter 6. This one is chapter 6.
你是这样子做？哦，我们啊，还没开始做。OK OK OK。可是你可以做这样子。
如果是6分是多少？
因为我看到一条电记录嘛，就讲人的一个那个什么，之前上个 semester 学的，可是它下面那些 stakeholder，这个 list stakeholder 吧，看，就 list 这改革吧，弄掉。这样做，还是这样做，看这个，没有吧？这个还有这个，看，这两个没动啊。一般就是这个，因为我这个记录哦，这个记录就是什么意思啊？这个。好的啊，对的，可是说他说的就是这样，我这边人读书是这样子。怎样做去形成一个状态？这样子吧，这个然后这个整个就形成了一个，这样子吧。
Okay, thank you, Brian. Okay, so we have a computer, right? Computer is a class, superclass. So, these properties are you rather be specific, lah? What is the properties? Maybe in this case, it's like common user. Okay, maybe I put a common user, and you can put a student. Okay, so laptop is generally small, so you have a two subclass, which is a laptop and desktop. Okay, so it's a computer. Okay, so it's a superclass, it's a computer, it's a computer. Okay, so instead of put a properties, everything here you give a name. Okay, maybe size. Okay, large. Okay, portability. Okay, portability. No. Okay, power. Supply. Okay, so you have to give what is a processor. Okay, something like this. Okay, yeah, so it'll be easy to read other than you just put properties, everything's here, so you put like this. So in this case, laptop. Okay, same goes to this one. Size, portability, the power supply, the processor. Then you click another frames here is a Acer. So this is one of the example. Right, one of the examples. So you can put instant. This one you can put instant. So instant. So if you put gaming laptop, means that it's actually inherit from different frame. So you can actually put laptop also. You can put laptop. Then you can put one of the properties. Main purpose. Okay, it's a gaming. You can put also gaming laptop, but then if you have a gaming laptop, it means that in between these two frames, you have to click another frame which is gaming laptop. Okay, and then this inherit the gaming laptop. Otherwise, you want to inherit only the laptop, then you just put the gaming as one of the properties. Okay, then yeah. Okay, very good. So just some improvement. Alright. So it's very important that you create the name, the class name here. Okay, so this is the first element, the name. The second one is the attribute. The attribute. The last one is the value. Okay. So you can actually refer more to more partial question lah. So yeah, due to time constraints, so I just show you some. So now I hope that you have a better idea of why do we need to represent the knowledge, because before we do any codings, we have to represent the knowledge easy for the machine for us to understand and do the codings. Okay, so we have 4 types. You have a semantic networks conceptual graph used to represent the events, the sequence of events used to represent the relationship. We use a frame to represent the properties, attributes, and last one we have an or graph to represent the rules. Okay. All right. So any last question before we dismiss? No, then Brandon, I need your help to find the day, common day for everyone here to have a midterm test. Either in the week 9 or week 10 after 6 lah, 6:30 to 8. So you see which day is free. Then you let me know. Okay. So let me know maybe by this week. You Google check me or email lah. Okay. Okay. So that's all for today. So thanks for your attention. See you next week.
那养它吗？
没钱，
嗯，
没钱。
那你有钱的话。
可是应该是让你